Let us start lecture 46, and the course is on phase diagrams in single component and binary systems. And the today's topic will be same as what we have done in the last lecture. That is, we will be treating a non-ideal solution, and on the basis of regular solution model, we are trying to find expression for del Hmix. What we have seen in the last lecture, we are talking about a binary solution. Between A and B, these are the two pure metals, and temperature and pressure are constant. Okay. And here number of atoms, if we consider Na and Nb, when we add them together, it yields me N0, which is Avogadro number. So, that means we are considering 1 mole of solution, and in fact, we have found out Xa mole fraction and Xb, and if we add them together, it becomes 1 mole. And Xa Xb is basically, if we divided Na divided by N0 and Nb divided by N0. So, that yields mole fraction of A and B in the solution. Okay. And we have taken some important assumptions. So, assumptions, those are chemical effect only. No other effect like strain, energy, valency, all those effects are ignored, and we have second is del V mix equal to 0, that means the volume dilation is 0, no volume change, and we are talking about molar volume change. Okay. That is 0. Third is bond formation with nearest neighbor, and the bond energy are coming off due to potential energy minima. Fine. Between two atoms, those can be EAA type, and what are the bonds we have considered? EAA, EBB and EAB, and all are negative. Okay. Fourth is crystal structure. Of A and B, pure metal A and B, as well as AB, all are same. It means that Z, which is the coordination number, so that is also same. Fine. And fifth is, we are considering that del S mix is only coming due to, which is R Xa ln Xa plus Xb ln Xb, that is only coming due to configurational effect. All other entropy terms like vibrational entropy, those are all ignored. Okay. So, on the basis of this assumptions, and remember these assumptions are very simple assumptions, and rather I would say simplistic assumptions, but still we will get an idea of solution formation, and in fact, we can explain some of the practical situations with the help of such simplistic assumptions. Now, we are actually trying to find out del Hmix, and why? We know that solution free energy is nothing but G2 equal to G1 plus delta G mix, and here delta G mix is related to delta H mix minus T del S mix, So, this term in case of ideal equal to 0, but non-ideal case this not equal to 0. It can be either positive greater than 0 or less than 0. Okay. So, those cases the free energy composition plot or the expression for solution free energy will be different if we compare ideal as well as non-ideal cases, because there this will have an contribution towards the free energy of solution, okay, which is J2. Now, we have found out an expression del E mix equal to PAB EAAB minus EAA plus EBB divided by 2. This expression we have found out. We have seen already these 3 bond energies, but PAB is the number of AB bond, AA is number of AA bond, and PBB is number of BB bond. And in fact, we have initially started with all types of bonds, and we have found out the bond values, bond number values of AA and BB as well, and then express the energy of the mix in terms of AB bond type. Okay. Once we have done that, now let us get into the next step, which is del H mix. Del H mix can be written as del E mix P plus del V mix. So, this is coming from the expression what we have learnt in the few earlier the few lectures what we have taken during the beginning of this particular course, and this is coming H equal to E plus PV, if you recall, and here this del E mix is actually nothing but the internal energy of the system, okay, which is coming due to the bond energies of all types of bonds. So, and P, and we have taken P is constant, and now let us take this is to be 1 atmosphere. Okay. Now, here that assumption what we have taken del V mix equal to 0 will be very useful. So, this is assumption we have taken. So, from here we can write del H mix equal to del E mix. So, this equal to PAB EAB minus EAA plus EBB by 2 this. Okay. So, del H mix equal to del E mix. Now, our sole interest would be to find out PAB, which is the number of AB bonds in the mix or solution. Okay. So, this will be our sole interest, and this will be found out with respect to Z, XA and XB. Before that, let us understand this particular expression. Now, case 1, let us say, case 1 EAB is more negative than EAA plus EBB by 2. So, that case, let us say this particular difference is considered to be, or we can say that del E mix is less than 0, or we can say that del H mix is less than 0. This particular EB value, EAB value is so highly negative then there could be a situation like this. So, extremely negative value. It suggests that AB bond is highly stable. Now, if it is extremely very high negative value, it means that A would always like to have a neighbor, B neighbor, and B would also like to have A neighbor, and they have a so strong interaction that they can also form like a kind of compound where the fraction of A and B in that compound could be a fixed number, okay, or we can say stoichiometric situation. So, that time we can experience formation of intermetallic compound. For example, in nickel titanium case, we can get intermetallic. So, there nickel and titanium have a very high interaction, okay, and that time AB bond, that is both are different type of bonds. So, this NiTi, both the atoms will have a strong negative interaction. So, they would like to form compound. Okay. Now, case 2, considering the same thing, EAB is more negative than this combined similar type of bond energies, then we can say del E mix can be less than 0, and that time a small negative. Previous case, since it is less than 0, highly negative. Okay. And in these cases, we can also write del H mix is less than 0, and this yields a situation where the interaction between A and B atoms will be strong, but it is not that strong enough to have a kind of stoichiometry between these two atoms. Okay. So, that time A would always try to find B atom in its near surroundings, and B also would like to have a kind of A atom in its near surrounding, but they will not form compound. So, that particular thing we call it as ordering, okay? And in fact, that order could not extend for a long periodic order, rather in a short distance that ordering can exist. Okay? So, we can have short range or medium range ordering. Okay. Now, case 3, so these are both cases del E A B, both cases this is less than if I try to look at or greater than if I talk about the mode values, only the values. So, that means EAB is more negative than EAA plus EBB by 2. Then case 3, and we can have another case 4 where EAB, if we take a mode value, would be less than this. So, it means that in this case it means EAB is less negative than by 2. Less negative, it can be then del E mix is greater than 0 or del H mix is greater than 0. Now, this difference could be so high that we can say that highly positive. Highly positive, that time A would like to have A type of atoms and B would like to have B type of atoms, because AA and BB bond, those bond energies are highly negative as compared to AB bond. So, the similar type of bonds will try to exist in the system. So, then we can have, in that cases we can have terminal solid solution. If I talk about solid and solid, if I talk about solid solution, so terminal solid solution we can experience. This is one example. Okay. Now, the case 4, we can same condition, but del Hmix is small positive, okay, or del Hmix small positive. So, that time definitely in this case AA and BB type of bonds would like to have its own neighbor. Okay. So, that means A would like to have A and B like to have B, but it is not that severe interaction of similar type of bonds. They would like to have in a very a short region, okay, or rather narrow region that can exist. So, that leads to one situation, we call it clustering. Okay. So, this clustering is due to a small positive nature of del Hmix. Okay. So, now we could see that with the help of this bond energy differences, we can actually relate to some of the practical situations where we can get intermetallic, where we can get terminal solid solution, that means similar type of bonds would like to exist, where we can get clustering, where we can get short range or medium range ordering. Okay. Now, with this, so let us now get to finding value of PAB. So, now and this value would be with reference to the mole fractions. Now, let us say one site in the lattice is occupied by A atom, okay, and the probability would be XA, that is the mole fraction of A in the solution. The next near neighbor site is also occupied by A atom. So, that probability would become equal to XA into XA equal to XA square. So, we can say that probability of finding a pair of A and A is equal to XA square. Similarly, we can also write for when we try to find out the probability of finding a pair of BB, finding a pair of BB would be equal to XB square. Okay. Now, if we try to find out the probability of finding a site with A atom equal to XA, the probability of finding its next neighbor site with B atom would be equal to Xb, then probability of finding a AB pair should be equal to Xa Xb plus Xp Xa. Now, why we have added this part? Because here we are talking about a site with A atom, we just make the site same site as B atom, that time it would be Xb, and here this B atom if we replace by A atom, that time it would be Xa. Okay. So, that time, so that is what these two term gives me, this gives me with reference to a site first occupied by B and its by A. So, this is nothing but this quantity. Okay. So, that is what we have to add that part. So, it becomes 2 Xa Xb. So, once we find that, then we can actually get the number. What is the, let us find out the number of lattice site pairs in the solution is nothing but half this. Now, we know in the solution the total number of atoms is basically Na plus Nb equal to N Avogadro number. So, that is basically number of lattice site pairs in the solution is half N0, that is Avogadro number into Z in that 1 mole of solution. If I go back, we can say that this is nothing but AA bond, because we are talking about AA pair. Okay. This is nothing but BB bond, and this is nothing but AB bond. Okay. So, now if I try to calculate the number of AB bond, which is PAB, should be equal to half Avogadro number Z into 2 Xa Xb. Okay. So, this is the total number of AB bond in 1 mole of solution. So, this equal to Xp. This Avogadro number, Z is the coordination number, Xa and Xp. And we can use this Z in the solution because we have taken that assumption, remember, A pure A pure A, pure B and AB solution all have same crystal structure, hence all have same Z or coordination number. Okay. So, hence del H mix is nothing but PAB this. So, then this is nothing but Avogadro number Z x a x b, and if we take this to be this. So, then del Hmix, and this is basically the difference of the bond energies of A B with A B plus B B minus 2 sorry by 2. Okay. So, then this is, now we can actually put it in terms of a kind of omega. It can be written as N 0 Z E. So, then del Hmix can be written as omega x b x a x b. Okay. So, now initially what we started, that we actually, so this tells us that this is a function of Z x a x b E a b E a a and E b b. Fine. Avogadro number is why we are taking Avogadro number, because we are talking about 1 mole of substance. So, finally, we get an expression. So, this will be our discussion point in future lectures, and on this particularly, in fact, this particular number could be highly greater than 0, highly less than 0, slightly greater than 0 or slightly less than 0. Okay. All 4 combinations we can see, and all 4 combinations can yield a different solution free energy, and shape of that solution free energy would also be different. Okay. So, initially we will start with analysis of the free energy composition plot considering del G mix, because del G mix has both the contributions, that is entropy of mixing contribution as well as enthalpy of mixing contribution, and we will try to compare with ideal case and see how the situation evolves. So, that will be part of our discussion in next set of lectures. So, let me stop here. Thank you very much.